Simplify numerical nth roots. So let's review what it means to talk about a radical. So remember, a radical will have a radicand, which goes under the radical symbol, and you'll see an index indicating which kind of root you're trying to take. So if we have an index like 3, this is known as a cube root. An index of 4 is a fourth root. And anything with an index of n is called an nth root. So a main idea is that the root is the inverse of a power. So let's think about how you'd solve the equation x squared equals 9. You know you can solve this equation by taking the square root of both sides. So we take the square root of x squared, and that equals plus or minus the square root of 9. So that gives us x equals plus or minus 3. So why specifically did we take the square root? We took the square root of x squared because the square root is the inverse of squaring something. So it's very important to keep in mind that the type of root you use to undo a power depends on the exponent. So if we're solving x cubed equals 27, we're going to use the cube root in order to solve. Okay, and that gives us our solution, which is x equals 3. If we're solving x to the fourth equals 81, we're going to use the fourth root in order to solve, and we can find our solution, which is x is plus or minus 3. X to the seventh equals 2187, we're going to solve by using the seventh root, okay, and that's going to be how we find the solution, which is once again x equals 3. So a main idea here is that when you're undoing a power, the index of the root must match the value of the exponent, okay? That's the only way it's going to be an inverse operation. Okay, so now let's talk about simplifying nth roots of numbers. So the product property can be used to simplify nth roots of numbers just like we do with square roots. And what you're going to do is look at the roots chart that's in your study guides and find the table that corresponds to the index, which is n. Determine the highest value in this table that can divide the number and write it as a product. Then take the nth root of the number based on the table and make it the coefficient of the radical. So if we're simplifying the fourth root of 48, remember that biggest fourth root that will divide 48 is going to be 16, okay? I can find this by going to Desmos, right? I'm going to do 48 over x, and then I'm going to click the gear, and I'm going to select table. Once I delete out all these values, I can type in the values for my fourth root chart going backwards. So the numbers that are less than 48, actually only 16 is, right? So if I type in 16, you can tell me that 16 and 3 are factors of 48. Okay, so we rewrite this fourth root of 48 as the fourth root of 16 times the fourth root of 3. And then we just simplify this because the fourth root of 16 I can see from my table is equal to 2. So this becomes 2 times the fourth root of 3. So these nth roots, they're all in the study guides that are linked in this lesson, okay? But the key here is that whenever you're working with a root, you have to figure out the index, and then the index of the root is going to tell you which part of this chart to use, okay? So be very careful that you're looking at that index and using the correct part of the chart. Okay, so let's start off with this example. We have the fourth root of 243. Okay, so you can see here my index is 4, so I'm going to go to the n equals 4 part of my study guide. Now what I'm going to do is I'm going to cross out all the values that are bigger than 243, and I'm going to go to Desmos and I'm going to type in those values. Okay, so I do 243 over x. I'm going to click this gear button, select table, and then I'm going to delete what I have here, and I'm going to type in those values instead, going in reverse order. So I have 81, and actually, you know what, 81 works, so I don't even need to go any further. So this is going to make my root turn into the fourth root of 81 times the fourth root of 3, right? Because those are the two factors I get from Desmos. Well, the fourth root of 81 is actually equal to 3, so I'm just going to go ahead and simplify this to 3. So I have 3 times the fourth root of 3 as my fully simplified answer. So now you can go ahead and pause the video and try doing this example on your own. So what I did here is I went to my cube roots chart, right? Because notice the index of this root is 3. So I want to go to the part of the chart where n is equal to 3. And then I'm going to cross out all the values that are bigger than 54. And I'm going to start here by going to Desmos and doing 54 over x. Then I select the gear and I got my table. And when I typed in 27, which is the first number I typed in, notice it does evenly divide 54. Okay, so I just rewrote this as the cube root of 27 times the cube root of 2. The cube root of 27, I can see from my chart, simplifies to 3. So I have 3 times the cube root of 2. So now let's try this example. So everything is going to be the same as before. The only difference is we have a coefficient to carry throughout this problem. So you can see here the index of the root is 5. So I'm going to go to the part of the chart that says n equals 5. So I'm going to keep that 3 always in front. And I'm going to think about how I can simplify this root by writing it as a product. So my radicand here is 160. So I'm going to go to my chart and cross out anything that's bigger than 160. So I'm going to go to Desmos and I'm going to do 160 over x. And then I'm going to select gear and then table. And then once I delete out all these values, I'm going to go ahead and type in 32. And you can see here that 32 does evenly divide 160. So I'm going to write this as the fifth root of 32 times the fifth root of 5. Well, the fifth root of 32 is 2, so I can just turn that into a 2. So I basically have 3 times 2 times the fifth root of 5. And 3 times 2 is 6, so this is now going to become 6 times the fifth root of 5. Okay, and that's now my fully simplified answer. So now you can go ahead and pause the video and try doing this example on your own. So I started doing this problem by looking at the index, which is 4, and then going to the part of the chart where n equals 4. So what I did is then I crossed out the values that were greater than 324, and I went ahead and typed them into Desmos. So you can see here 256 doesn't evenly divide 324, but 81 does. So I rewrote 324 as 81 and 4, so I have 2 times the fourth root of 81 times the fourth root of 4. The fourth root of 81 will turn into 3, so I have 2 times 3 times the fourth root of 4, so this now becomes 6 times the fourth root of 4. So one thing we need to think about when we're talking about roots is depending on the value of the index n and the value of the radicand b, a radical can have 1 real root, 2 real roots, or no real roots. So if our radicand is positive, okay, if the value under the root is positive, and we're taking an even numbered root, like a fourth root or a square root or a sixth root, we can have a positive or negative value, right? And we've seen this before. When we take the square root of 81, we get plus or minus 9. When we take the fourth root of 81, we get plus or minus 3, okay? On the other hand, if we're taking an odd index, okay, of a positive value, we end up with 1 positive real root. If we have a radicand that's negative and we're taking an even numbered root, that's going to have no solution, okay, because there's going to be no real root. And we saw something similar to this when we were working on square roots and we were taking square roots of negative numbers, right? Remember that resulted in imaginary numbers. If we're taking a negative radicand and we're finding an odd numbered root, on the other hand, we do have a solution. Okay, so this is something that's a little bit different that we need to keep in mind. If we take the cube root of something like negative 64, we're going to get negative 4, because if you think about it, negative 4 multiplied by itself 3 times will actually give us negative 64. Okay, so this is something a little bit different. Any root of 0 is always going to be 0, okay, because 0 multiplied by itself any number of times is always going to be 0. So if you need a list of these negative roots and what happens when you have negative radicands and those odd indices, those are also included in your study guides for your reference. So now, just based on what we talked about, I just want you to think about for a minute which one has a real solution and which one does not. Explain why or why not. So the answer to this question is you have to look at the index, okay? So here you can see we have an odd index, okay? We're taking an odd index of a negative radicand, so it does have one solution. It is possible to find an answer to this problem. On the other hand, you can see here my index is even, and I'm taking an even index root of a negative value, and that means I have no solution, okay? And you can actually use Desmos to confirm this if you can't remember when do I have one solution, when do I have no solution. To type in higher power roots on Desmos, you can use the shorthand nth root. So you just type n, th, and then the word root, and it will automatically create that symbol for you. Okay, so up here you can type the index, which is 5, and you type negative 160, and you can see here it does give me a real number as my solution. If I go to the next row, there's another way to do this. You can also go to the functions menu and scroll all the way to the bottom to number theory and select the nth root symbol, and then type the index, which is 4, and then negative 64, and you can see Desmos tells me that's not defined.